On to the second talk, which is David Grove, and it's on Powerleaf Federated Virtual Machines.
Okay. All right, yeah, so this is very much a workshop presentation. This is a project that we're doing in research that's very leading edge, lots of high-level concepts, no real results yet. So we think of this is what we're working on now, what we're thinking about, and we like to sort of just have a discussion about these kind of issues. I've tried to shoot for like a 15-minute talk with time to talk about things, so that'll at least get us back on a schedule if no one's interested. Okay, so what is Parlay all about? So the motivation has really been driven by some of the things that Bob was talking about earlier this morning, is we sort of see virtual machines being increasingly important, and that heterogeneity, for better or worse, is reality. There are going to be lots of different programming languages, there'll be different managed runtimes, and people really want to interoperate between these things. You don't want to be forced into particular language models for the entire solution, just because that's what you need to do. So you want these VMs to be able to interoperate in a very nice way. So the scope of the research project is really, there's two pieces. There's VM support for how do you build VMs and support this kind of operation in VMs. And then there's, supposing the VMs all magically actually did this, what does it look like to the programmer? And so we're assuming a certain amount of IDE support where IDEs will understand this interoperability and expose it to programmers. And I'm not talking about that at all today. So this is just sort of the VM technology of how do you get these VMs to talk to each other, and the program magically is written in some other way. So what I'm going to talk about is basically just sort of think there are three approaches for interoperability, and then just going to go through this really quickly and talk a little bit more about how we think Parlay is going to work, and tell you where we are, some extensions to this basic Parlay model and where we are now, and then hopefully have time for discussion about whether or not this is viable and what people think of where it could go in the future. Okay, so there's three approaches for interoperability. The first one is really epitomized by the CLR. You have one virtual machine. You compile the whole languages A to Z, all get compiled into a common format. That's what this VM actually speaks. It's not a multi-language VM. It's a VM that talks a language, one language, and all the languages that get compiled into it. So at the VM level, there is no language interoperability. There's this language, it runs it, and everyone else compiles into it. It's nice in that you have this VM, you can leverage your investment in VM infrastructure across a family of languages. There aren't really a lot of serious interop issues because at the VM level, there's just one language, and things are relatively simple. Some of the disadvantages we see, which I think are fairly non-controversial. So not every language can be jammed into, you try to make this as general as possible, and you try to think about it. There always will be some new language that will have some new feature that won't fit. And as you sort of get further away from the core set of languages, you've got to make compromises. There'll be some special feature that has to get cut off, or that just won't really be exposed in the right way. The monolithic VM also makes it harder to innovate and evolve. If you want to make language changes or VM changes, this is a fairly big piece of software. It's harder to evolve it than a single language VM. And there's all these legacy VMs and legacy, probably more seriously, legacy programs, large programs that depend on the exact semantics of particular programming languages. If they can't be compiled with true fidelity into this common language infrastructure, the programs have to change, or you've got some problems to deal with. So there's a second obvious way to do interoperability. There are commercial various companies that will sell you things that translate from Java to CLR and so on via this sort of loosely coupled interoperability solution. And the idea here is basically, you've got this VM, you've got that VM, some languages run here, some run over there, and if they want to talk to each other, we know how to talk, we talk over sockets. Right? And so you come down through some native code, out to some other process, back up, and there's tooling, there's people will sell products that just sort of generate the tooling to make this all sort of just happen. So that's great. And if you're only crossing this barrier occasionally, it's not so bad. Right? If you're crossing this once in a blue moon, the fact it might take you forever to do it doesn't really matter. And the other sort of disadvantage is the programming model is you tend to be exposed to the fact you actually are crossing a process boundary. Instead of passing something by reference, you're doing some kind of marshalling. And tooling can generate a lot of that stuff for you, but it is definitely, you have to be aware of this at the application level, that there's something going on here that's not just passing you an object and you're going to do something with Okay, so what we're trying to do with Parlay is do something in the middle where we have a set of VMs with this interop layer. All the VMs are in the same process, right? And so the VMs are modified. We still have multiple VMs. You pick the VMs, whatever language, whatever VM is sort of the appropriate one for your language or if your existing application, you can still use it. That VM is modified to talk to this interop layer. And so cross-VM communication just sort of happens all within the same process via function calls and additional stuff. And so so this allows VM heterogeneity. You can pick VMs that best match whatever it is you're trying to do, legacy VMs, new VMs for new language features. You can't allow high performance to cross these things. You're at least probably very likely to be better than IBC. I'll talk a little bit more about that. And assuming that we also, the other half of the research project, which is so taking this interop layer and also exposing it to IDEs. So there's this interop layer that allows VMs to talk to each other, and that same interop layer can also be used in the tooling so that an IDE can query this interop layer about artifacts in other languages and how to expose those within its own language. So the programming model can actually be relatively unchanged. You can we sort of envision surfacing components in some language over here to a program over there as if they were components in his own language. And then the interop layer deals with actually making that happen at runtime. Okay, so the big disadvantage is this orange box is intersecting this blue box. There's actually work that has to be done inside the VM to make this fly. You can't just take a VM and not modify it for this. Okay, so what I'm going to do now is so this is just expanding a little bit more on that last point. So there's sort of three reasons why we think this is an attractive avenue to pursue, especially as a research project. So the VM heterogeneity is useful both for sort of dealing with multiple vendors having their own VMs to deal with, the reality of there being multiple VMs out there with large installed bases on them that want to interoperate. But it also allows sort of more evolution. You don't have to evolve the entire stack of everything in the world in lockstep and you don't have to have as much coordination to add a new feature to the VM. If there's some VMs that want to evolve more rapidly than others, that's okay. If there are languages that have specialized requirements, custom type systems, there's been a lot of interest within my own little piece of research recently in ownership types, and can we do things with those in the language model? So that's something you might want to add to a VM in an experimental fashion, but maybe you don't want to invest in putting in a production VM yet. So you can sort of have these internal customized things that you don't have to surface at the interop layer that will allow you to evolve VMs and language models without having to sort of truck everything and start over. You can have a component that's written in a new language that still talks to all of your old VMs and old languages. So just to have some more gratuitous animations, here's some foilware of how it's sort of stepping through a basic Parlay interop scenario. And so assume we have some program written in language A that wants to utilize some component written in a foreign language, Z. So, and the program has been magically written and it exists. And so you've got this program in A, you start it up, it's an A program, so we fire up a VM for A. As part of VM initialization, it hooks into the Parlay interop library, sort of initializes the library, registers the VM and tells the interop layer what languages it understands and what it's capable of doing. The program runs along, just doing its own thing. At some point, it accesses some foreign resource. So it accesses a resource, its own VM doesn't know what to do with this. It has a file extension or whatever your mechanism is for loading a resource. This VM doesn't know what to do with it, so it calls into the Parlay library and says, hey, my program wants this, find some VM that can deal with this and make it happen. So at that point, Parlay, if it knows a VM that's capable of doing that, will go off, initialize a VM, bring up a VM for that other language, cause the component to be loaded, initialized, ready to go, and then sort of come back, and the application and the component can interact with each other relatively directly. There is some mediation that goes on with Parlay to make this happen, but not everything